Here's a review of some important information from the tutorial on writing chemical formulas. Chemistry has a language all of its own. Element symbols are used to form chemical formulas, which are then used to form chemical equations. Atoms are neutral, ions have charges. Metals lose electrons, resulting in cations, which have a positive charge, while nonmetals gain electrons, resulting in anions, which have a negative charge. A polyatomic ion is a group of atoms bonded together that have a net overall charge. Binary ionic compounds will contain two elements, one metal, one nonmetal. They are bonded together by the transfer of electrons, resulting in ions that are attracted to each other. Type 2 is a polyatomic ionic compound, a compound containing at least one polyatomic ion. Type 1 and Type 2 can both contain multivalent metals, which are metals that have more than one possibility for their positive charge. Type 3 compounds are made of two nonmetals that share electrons, forming a covalent bond. And Type 4 is acid, which by the Arrhenius definition designates a compound that donates a hydrogen cation to water to produce the hydronium ion. The charges of some ions can be determined by their position on the periodic table. Here are some common polyatomic ions. Notice that ammonium is the only polyatomic cation. The rest are anions and will appear in the back half of the compound's name. Also, the charges given are for the entire polyatomic ion as a whole and do not need to be multiplied by the subscripts within the polyatomic ion. Here's a refresher of the prefixes used in covalent compounds. The first type is binary ionic compounds. First, write the name of the metal, the cation. Second, write the name of the nonmetal, the anion. Remove the ending of the nonmetal's name and add the suffix IDE. The subscripts in this formula do not matter when naming this type of compound. For example, NaCl. Na is the cation, sodium. Cl is the anion, chlorine, which becomes chloride, sodium chloride. CaBr2. Ca is calcium. Br is bromine, which becomes bromide. Notice in this type, one metal, one nonmetal, the subscripts are not important when naming the chemical. Another example is K2O. K is potassium. O is oxygen, which becomes oxide, potassium oxide. The next type of compound to name is the polyatomic ionic compound. Write the name of the metal or ammonium, which is the only cation polyatomic ion. Write the name of the polyatomic ion. Do not change the ending of a polyatomic ion. The only polyatomic cation is ammonium. Otherwise, look in the back half to find the polyatomic ion. If a compound has parentheses, the polyatomic ion is inside the parentheses. Subscripts are important when naming polyatomic ions. The subscripts within the polyatomic ion must match exactly. An example, NaNO3. Na is sodium. NO3 is a polyatomic anion, nitrate. Sodium nitrate. K2SO4. K is potassium. SO4 is a polyatomic anion, sulfate. The 2 with the potassium is not important for naming this type of compound. The only subscripts that are important for this type are subscripts within the polyatomic ion. Potassium sulfate. Ca parentheses OH parentheses 2. Ca stands for calcium. Whenever you see parentheses, the polyatomic ion is inside those parentheses. This polyatomic anion is hydroxide, calcium hydroxide. Parentheses NH4 parentheses 2S. Remember, the polyatomic ion is inside the parentheses. This is the only one that will come in the front half of a compound. Ammonium. S is sulfur, which becomes sulfide. You do not change the ending of a polyatomic ion, but if the anion is a single element, change the ending to IDE. Ammonium sulfide.